Today we are going to study the higher order homogeneous linear ODE constant coefficients. So the general form is y raised to n plus a n minus 1 y raised to n minus 1 plus a n minus 2 y raised to n minus 2 etc. a2y square plus a1 y plus a0 y is equal to 0. So there are three cases. First case, if m1, m2 and m3 are distinct and real, then the solution is of the form c1 e raised to m1x plus c2 e raised to m2x plus etc. cn e raised to mnx. So next second case is if two roots, that is m1 and m2 are equal and other roots are distinct and real, then the form is y is equal to c1 plus c2x into e raised to mx plus c3 m3x plus etc. cn e raised to mnx. So next, if three roots are equal and other roots are distinct and real, then we can use this. Case 3, if one pair of complex roots and others are real and distinct, so the form is y is equal to e raised to x into c1 cos bx plus c2 sin bx plus c3 e raised to m3x plus c4 e raised to m4x etc. cn e raised to mnx. So next, in the case of multiple complex roots and others are distinct and real, then this is the form. First question, y raised to 4 minus y is equal to 0. So convert it in the terms of m raised to 4 minus 1 is equal to 0. So square minus 1 is equal to 0. Minus 1 into m square plus 1 is equal to 0. Square minus 1 is equal to 0. M square is equal to the roots are m is equal to 1 minus 1 plus or minus I. Then we can write it in the form that is general solution of the corresponding roots. E raised to ax into c1 cos bx plus c2 sin bx plus c3 e raised to m3x plus c4 e raised to m4x. So which is equal to e raised to 0x into c1 cos x because b is 1 plus c2 sin x plus c3 e raised to x plus c4 e raised to m4x. Sorry, m4 not, c4 e raised to minus x. Answer is c1 cos x plus c2 sin x plus c3 e raised to x plus c4 e raised to minus x. Question number 2, y raised to 4 plus 2y double dash plus y is equal to 0. So write in the term of m raised to 4 plus 2m square plus 1 is equal to 0. So finding the roots are m is equal to plus or minus I. The general form, y is equal to e raised to ax into c1 plus c2x cos bx plus c3 plus c4x into sin bx. Next, y is equal to e raised to 0x which is equal to 1 into c1 plus c2x cos x b is equal to 1 plus c3 plus c4x into sin x. Question number 3, convert it in terms of m cube minus 2m square minus 5m plus 6 is equal to 0. So the roots of m are m is equal to minus 2, 3, 1. So putting this values in our general form, y is equal to c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x. So y is equal to c1 e raised to m1 is minus 2, so minus 2x plus c2 e raised to m2 is 3, so 3x plus c3 e raised to x. Question number 4, convert it in terms of m cube minus m square minus m plus 1 is equal to 0. So the roots are m is equal to minus 1, 1, 1. Then y is equal to c1 plus c2x into e raised to mx plus c3 e raised to m3x. Y is equal to, because 1, 1 these are equal roots. So c1 plus c2x into e raised to x plus c3 e raised to minus x.